All right, 9, 2, multiplying and factoring. Let's just warm up a little bit here. 3 times 302. Well, 3 times 300 would be 900. 3 times 2 is 6, so this would be 906. 41 times 7. I would think of 41 like 40 plus 1. 7 times 4 is 28, so 7 times 40 would be 280. Plus 7 times 1 is 7, so that would give me 287. Look at us using our brains. 9 times 504, I would change 504 in my head to 500 plus 4. 9 times 5 is 45, so 9 times 500 would be 4,500. 9 times 4 is 36, so 4536. Simple distribution here. 4 times 6 is 24. 4 times 5x is 20x. I'm going to go right underneath it while I'm here. That would give me 7p minus 14. Look at us just multiplying, warming up with some simple distribution. You should have been able to do this back in chapter 2. This would give us negative 16y minus 8. Underneath, if we multiply these by 9, 9 times 6 is 54. Minus 9 times x is 9x. Over here, 5 times 5v is 25v. Minus 5 times 1 is 5. Last one, negative 2 times 4x is negative 8x. And negative 2 times negative 1 is positive 2. All warmed up, ready to go. Let's get to the nasty new stuff. Here we go. Oh! Now, here's where your old chapter 8 exponent properties comes into play. We've done problems where it's just said negative 4y to the second times 5y to the fourth. We've done that already. You do negative 4 times 5 is negative 20, and then when you have the same bases, they're both y's, you add the exponents when you multiply. So 2 plus 4 would be 6. This is the same thing, except we just have to do it 3 times. It's like 3 problems in one. So negative 4 times 5 is negative 20, and we add the exponents. Y to the second times y to the fourth would be y to the sixth. Now here we have a negative times negative. I know that's plus. 4 times 3 is 12. Y to the second times y to the second. We add the exponents, and it's y to the fourth. Here, negative 4 times 2 is negative 8, and we just have y to the second. Make sure it's in standard form, your highest exponents first. Good, 6, 4, 2, great. Here we go. Let's try 3 more. We're multiplying these all by 4b, so we're multiplying the number in front by 4, and we're putting one more b on the exponent. So 4 times 5 is 20. B to the first times b to the second is b to the third, 20b cubed. Now here I'm doing 4b times 1b. 4 times 1 is 4. B times b is b squared. And 4b times 6, 4 times 6 is 24. And then it's just the b. 4b times 6 is 24b. All right, negative 7 times 3 is negative 21. H to the first times h to the second is h to the third. Here we have a negative times negative. I know that's going to switch to positive. 7 times 8 is 56. And then h times h is h to the second. Here we have a negative times negative. That's positive. 7 times 1 is 7. And then we had the h to the first. Last one, 2x times 1, x to the second. 2 times 1 is 2. X to the first times x to the second is x to the third. 2 times negative 6 is negative 12. X times x is x squared. 2 times 5 is 10, and we just have the x, so 10x. That wasn't too bad. Now, our next step is we're going to get this, and we're going to have to turn it into this. So this number outside is called our greatest common factor. It's the largest thing that goes into each of these 3 terms. That's going to be a little tougher to find, but we got this. Find the greatest common factor, GCF, of those 3 terms. So what I like to do is I look at the numbers first. We have 4, 12, and 8. You might be like, hey, 2 goes into all those. That's true, but it's not the greatest common factor. 4 goes into all of those. So 4 would be the greatest common factor of those numbers. Do they all have x's? They do. Do they all have x to the second power? No. So when they all have x's, you look actually for the smallest exponent. We have x to the third, x to the second, x to the first. So they all have at least x to the first. So 4x is the greatest common factor, the greatest thing that can be multiplied into all of these terms. So if you look at A here, look at the numbers in front, 5 and 10. What goes into both of those? Well, 5. It probably jumped out at you. For the variables, you got to go with the smallest one. They both have v's, and the smaller one is 3. So we'd say they both have at least 5v to the third. That's our greatest common factor. If you look at B, 3t squared minus 18. You look at the numbers, 3 and 18, and I'm like, great, 3 goes in there. Do they both have t? No, they don't. So we can't say they have a t in common. So our greatest common factor is just 3. And here we go, 4b to the third, 2b squared, 6b, 4, 2, and 6. I know that 2 goes into all of those. Do they all have b? Yeah, they do. They all have at least b to the first power. So you could write 2b to the first, but why would you? 2b to the first is 2b. We're smarter than that. We don't need to write 2b to the first. We're cool like that. This is the first step of factoring. Always look for the greatest common factor. So that's what we're going to do now. Factor out a monomial. So looking at this first one, 3x to the third minus 12x to the second plus 15x. Looking at the numbers 3, 12, and 5, I know that 3 goes into all those. Do they all have an x? Yes, they all have at least x to the first power. Now it's essentially a fill-in-the-blank problem. We're saying 3x times something gives me 3x to the third. Or, what we're also doing is we're technically dividing each of these terms by 3x. So we're doing 3x to the third divided by the 3x that we factored out, minus 12x to the second divided by 3x, plus 15x divided by 3x. You can do that each time. I don't think it's necessary. I'd like you to start thinking about it like this. 3 times what gives me 3? And you're like, 1. Okay, you could write the 1 there. Let's write it for now. I have x to the first. I need x to the third, which means I need 2 more x's. 1x squared. Or if you did it like this, 3 divided by 3 is 1. X to the third divided by x to the first. Our old exponent properties would say we'd subtract those exponents. So you'd get 1x squared that way too. Cool, it works. Now we're saying 3 times something gives me 12. Well, 3 times negative 4 gives me negative 12. I kind of forgot about the negative there because I already wrote it in. Now I have x. I need x to the second. So I need 1 more x. And the last term, 3 times what gives me positive 15? 3 times positive 5. I have x. I need x. So we don't need any more x's. So the only thing I would have you do probably with this is just clean it up. 3x, this 1x squared, I would just have you write as x squared minus 4x plus 5. So I know this is new and different, but let's try these pretty quickly here. 8x squared and 12x. 4 goes into both of those, and they both have an x. So 4, I need 8. 4 times 2 gives me 8. I have x, I need x squared, which means I need 1 more x. So 4x times 2x will give me 8x squared. 4x times negative something gives me negative 12x. Well, 4 times 3 is 12, and we already have the x. So that would be our final answer. Looking at B, 5d to the third plus 10d. 5 and 10, they have a 5 in common. Do they both have d? Yeah, they both have at least d to the first power. So again, we're dividing by 5d. Or 5d times what would give me 5d to the third? We already have the 5. We have d to the first, and we need d to the third. So we need 2 more of those. So d squared 5 times 2 is 10, and we already have the d handled. So that would be it. And then on C, looking at the numbers 6, 12, and 24, 6 goes into all of those. They all have at least m to the first power. I'll throw in my signs there. I just brought them right down. 6m, I need 6m to the third. What's missing? M squared. I have 6m, I need negative 12m squared. Well, 6 times negative 2 handles the negative 12. I have m, I need m to the second, so I need one more m. And 6 times negative 4 gives me that negative 24, and I've already got the m handled, so we're all done. Look at us, factoring out the greatest common factor, like pros.